You know, every home has an unsung hero. It's this piece of tech you probably never see, never even think about, but it's working for you 24/7, keeping you comfortable and actually saving you money. We're talking, of course, about thermal insulation, and today we're going to pull back the curtain and see exactly how it works.
So, have you ever noticed that one room in your house is always an oven while another is an icebox? Or maybe you feel like your air conditioner is just running and running and running and barely keeping up? Well, that's not just your house having a personality. There's an invisible force at play, and it's hitting you right in your comfort and your wallet.
And here it is. This is the culprit. Heat transfer. See, heat has one simple mission in life. It wants to move from a warm place to a cool place. So in the summer, all that blistering heat outside is desperately trying to sneak into your nice, cool house. And in the winter, all that cozy warmth you paid for is trying to escape. This is a constant battle, happening right over your head and in your walls.
To really get a handle on this, let's frame it like a classic showdown. In one corner, we have our hero, the solution. And in the other, we have its nemesis, the problem it's built to fight.
So, let's meet the hero of our story. Thermal insulation. Its one and only job is to stop that heat transfer dead in its tracks. You can think of it like a protective shield for your home that slows the movement of heat way, way down, whether that heat is trying to get in or out.
Of course, every hero needs a villain. And in this story, our villain is a sneaky property called thermal conductivity. It's just the natural ability of any material to let heat pass right through it. You know how a metal spoon gets super hot in a cup of coffee? That's high thermal conductivity in action. The entire goal of insulation is to find materials with the lowest conductivity possible.
Okay, so what's the big payoff for winning this fight against heat? Well, it turns out the benefits are huge, and they go way beyond just feeling a little more comfortable. Let's really dig into why this stuff matters so much.
It creates this amazing chain reaction. First, you just reduce the amount of heat moving around. Because of that, your AC or your heater doesn't have to work nearly as hard, which means, boom, you use less energy. That leads to a much more stable, even temperature inside your home. And on a bigger scale, using less energy means reducing greenhouse gas emissions. It's a win for your bank account, a win for your comfort, and a win for the planet.
And let's not just gloss over that point about a stable temperature. This is huge. We're talking about your actual day-to-day quality of life. No more hot spots, no more chilly drafts. It's that simple feeling of just being comfortable in your own home, and you feel that benefit every single day.
All right, so now we know why insulation is a game changer. Let's get into the what. What is this stuff really? Because it's not just one thing. There's a whole lineup of different materials and forms. Let's go on a quick tour.
You can pretty much sort them in two main ways. First is by structure, what they're actually made of. That could be organic stuff, inorganic materials, or even metals. And the second way is by their shape, the form they come in. Are they loose grains, a spray-on fluid, big rolls, or solid sheets?
So for example, you have organic insulators like this cellulose here. It's basically made from recycled paper and comes as these loose grains. You blow it into an attic and it creates this deep, fluffy blanket that traps millions of tiny air pockets. And really, it's that trapped air that does the heavy lifting of stopping the heat.
Then you've got something totally different, like metallic materials. This is essentially a high-tech aluminum foil that comes in these big rolls. It doesn't work like a blanket. It works like a mirror. It actually reflects radiant heat away, which makes it super popular in places that get a ton of sun.
And get this, some insulators actually start out as a liquid. This is spray foam. You apply it as a fluid and it expands like crazy to fill every single nook, cranny, and crack. Its superpower is creating an almost perfect air seal, so it stops drafts right in their tracks, on top of slowing down heat.
And finally, you have insulators that come as these preformed rigid boards. These inorganic sheets are really strong and moisture-resistant, which makes them perfect for insulating things like foundations or the outside of your walls. So you see, there's a different tool for every single part of the job.
Okay, so this brings up a really crucial point. With all these different options out there, how do you know which one is the best? Well, the honest truth is, they are definitely not all created equal when it comes to fighting heat. And it all comes back to that one magic number we talked about, thermal conductivity. The rule here is incredibly simple. The lower the conductivity number, the better the material is at stopping heat. That's it. Lower is better.
And when I say the performance gap is big, I mean it can be absolutely massive. Just look at this. We're looking at two extremes here, but it makes the point. On the left, a high-tech vacuumed panel has a conductivity value that's practically zero. It's an absolute fortress against heat. Now, compare that to rubber over on the right. The visual difference says it all, and it just goes to show how much your choice of material really, really matters.
So, from this invisible battle against heat transfer to all the different materials we stuff in our walls, we've seen how this unsung hero is constantly working for us. And it leaves us with a pretty cool question to think about. As our climate keeps changing and energy gets more and more precious, what will the next generation of insulation even look like? What new materials and technologies will become our home's next unsung heroes?